Okay, now there's a lot of math words in there, isn't there? The point lies on the terminal side, angle, theta, standard position, and then you have all the trig functions. So what you want to take away from this is you have a point, and it's on the terminal side of an angle. That angle's in standard position. So where you want to start with these first is just plotting the point. And for every single one of these, you must draw a diagram. That's the whole point. So let's mark 8:15. It doesn't have to be a work of art. Just go ahead and pick a spot, give yourself plenty of room to plot it. Okay? So far so good, right?
Yep.
Now we get to draw the angle in standard position. Now remember, angle in standard position, the initial side, initial meaning start, it always starts on the positive x-axis. The terminal side can be anywhere. That's the one that spins. That's the ray that spins around, either positive, which is counterclockwise, or negative, which is clockwise. But it starts at x. So it's going to open up, and it's going to stop when it can intersect or go through this point. Does that make sense? So that's what the actual question is describing. It's describing an angle in standard position that goes through that point. Okay? All right, now, I drew the picture, and you have to draw that for everyone. The big skill here is finding the sine, cosine, and tangent of that angle. The angle is theta. So we always use that theta usually in trig to name the angles. So we do sine, cosine, and tangent of angles. But now we're doing them not in triangles, we're doing them on a circle, basically. So what you have to do is make a triangle. Okay? So what you do, Mark, is you go to that point. Zoning out on me, huh? You're going to drop a perpendicular. A perpendicular. Now do you see the triangle that got formed? Okay. Now do you see the angle in the triangle?
I remember you got the 8.
Oh, yeah.
And then you labeled the right triangle.
Right. So the first thing I did was I sketched the point and angle. Second thing I did was I drop a perpendicular. And the third thing was I'm going to label my triangle. Okay? So yesterday, the reason why we did the circles yesterday and finding the radius from a point was to get you used to labeling sides. Now, how long is this length here? How long is that side of the triangle?
8.
Mm-hmm. It's the x-coordinate, basically. Same thing. All right? And this side would be 15. Now, I'm going to need the sine, cosine, and tangent of this angle. That means I'm going to need the hypotenuse. The sine, cosine, and tangent, 2 out of the 3 need the hypotenuse. If it only asks you for tangent, don't need the hypotenuse, right? Now, so this is an 8. You can use Pythagorean theorem. 8 squared plus 15 squared has got to be equal to the hypotenuse squared. Right? Leg squared plus leg squared, hypotenuse squared. So this is going to be 64, and 225 is going to be 289 is the hypotenuse squared. So you know the hypotenuse is going to be the square root of 289, which is 17. I made all the problems Pythagorean triple, so there's no radicals I'm going to deal with. Okay, so this side right there is 17. Anybody lost so far? Okay? So now it's as simple as just reading the triangle. Okay? Now, we want the sine. Remember, for that angle, this is the opposite side. This is the hypotenuse, and this is the adjacent side. So the sine of theta is the opposite over the hypotenuse. So the sine of theta is the opposite side, which is 15, over the hypotenuse, which is 17. Check the fraction to make sure it doesn't have to be simplified. It doesn't. The cosine of theta is the adjacent of the hypotenuse. 8 over 17. Anybody want to raise their hand and take a shot at the tangent? Take a shot at the tangent, anybody? Be brave. What's the tangent? Jack, what do you think?
15 over 8.
15 over 8. It's the opposite of the adjacent. So the tangent is 15 over 8. Now, here's a good thing to note, save yourself some work. If the problem only asks me for the tangent, would I need to bother with the Pythagorean theorem? This is going to save you work. It doesn't matter to me if you go to find the hypotenuse, you don't need to. Right, if it asks you for the tangent, you don't need to find the hypotenuse because it needs the opposite side and the adjacent side. So if you catch that, it's helpful because you'll realize you'll find the hypotenuse and then you'll go to it and you'll say, wait, I don't need it. So just a little heads up first. Okay, so that's really how you're going to do this. We're going to stay in the first quadrant. We're not going to get fancy. Any questions? You okay? All right. So that problem set that I gave you has about 8 of these problems to practice on. Then it has some review of coterminal angles, converting from radians to degrees, and all that stuff from before the break. So you'll continue on with that. I'll walk around and give you guys a hand. Go ahead and get to work.
On